Today I wanted to talk about Venus, the sister planet of planet Earth. The planet on which the scientists recently made quite a lot of very intriguing discoveries. Discoveries that can actually help us understand how this planet evolved early on, what's happening on this planet right now, answer the questions about the possibility of life here, thus encouraging future exploration missions to this beautiful planet. And a lot of this is going to be based on many different studies from just the last few months, a lot of which discovered things about Venus we actually did not realize at first, or some new ideas that might have been not understood correctly before. With one of the most recent papers that just came out a few days ago, essentially focusing on the idea of plate tectonics or continental plates potentially being present on Venus. And that's because previously it's always been assumed that one of the reasons Venus is so extreme, basically so hot, so acidic, has so much pressure, is really because it just doesn't have any way to recycle all of the atmosphere back into the continental crust. Because on Earth this is done through plate tectonics, creating an absolutely essential cycle in order to maintain more habitable conditions on the surface, which then leads to the continuous renewal of the surface of the entire planet. And so for many years, it was believed that Venus has what's known as the single plate stagnant lid regime, essentially just having one single plate instead of having many like on Earth. But for many years, some scientists debated this, especially based on the observations from the atmosphere. Because here, by analyzing atmospheric abundance of certain elements, it became pretty clear that something else must be happening here, because the CO2 levels, the nitrogen levels, and even the surface pressure should technically be much higher and just overall appear very differently. With the initial explanation being that maybe Venus still has something going on the surface, changing things just a little bit once in a while. But a much more recent study discovered something else a little bit more intriguing. Here they used modeling, in essence trying to recreate Venusian conditions by changing geological formation over a period of 4.5 billion years. And in the process they discovered that in order to create modern Venus, you actually did have to have at least some plate tectonics for the first billion years of the existence of the planet. In essence suggesting that between 4.5 and 3.5 billion years ago, both Earth and Venus potentially had very similar effects on the surface, including plate tectonics. But later on, the planets went their own separate ways. The surface of Venus solidified, eventually forming conditions we have today, and that's because nothing was recycled anymore, so the gas just accumulated on the surface. But on Earth it was constantly recycled, and thus allowed for sustainable conditions. Although here this of course implies that maybe, just maybe, life could have also formed on Venus as well, because the conditions were possibly extremely similar to Earth, which basically suggests this type of a transition could be very common in a lot of other exoplanets. This is actually a very intriguing model. But it also takes us to our next point, life. Can there still be life somewhere on Venus? And the thing is, the chance for microbial life to thrive here is actually not zero. With at least 2 studies you can find in the description below, specifically focusing on identifying reasons why it's very likely possible. And that's because in the clouds of Venus, specifically about 50 kilometers above the surface, the overall temperature and the overall pressure, surprisingly, is extremely similar to planet Earth. Basically here we have 1 atmospheric pressure and a temperature of about 20 degrees Celsius. Although it might be actually just a little bit too acidic. There is quite a lot of sulfuric acid present in these clouds as well. But this is obviously not the first time such a proposition has been made, and some of the previous videos in the description talk about this a little bit more. But what the scientists did this time is actually explain how this is physically possible. Here they focused on 2 things. First of all, how can life even stay afloat and not fall to the ground? And here they propose several concepts, including the idea behind gravity waves, which are waves generated in the atmosphere, which can continuously push tiny particles to a much higher altitude. And also the concept known as negative photophoresis, which essentially focuses on the idea of light itself, or the heat from the light, causing certain particles to move higher and higher in the air. And both concepts actually suggest that particles containing bacterial life can indefinitely stay afloat and never fall to the bottom. But what about the acid? And here the second paper tested that as well. They actually tested whether nucleic bases, that basically DNA is made out of, can stay stable inside sulfuric acid. And they did this by putting a bunch of nucleic bases, such as for example adenine, cytosine and guanine, into very similar conditions, but inside a bottle of acid. In the process discovering that it seems to be just fine. All of these nucleic acids remained stable for several weeks and did not break down at all, implying that the life here can definitely survive, assuming it found a way to adapt to all of this. And that's of course on top of the previous potential detection of things like phosphine detected back in 2020. And so yeah, life on Venus right now does have a very high chance to maybe exist, which is why missions to Venus are so important. Luckily, at least 3 missions are going to be happening anywhere between 2029 and 2031, and so we might discover something in the future. You can learn more about these missions in the videos in the description. But when it comes to Venusian atmosphere, there is actually another mystery not related to life. And here it's the mystery of unusual flashes seen as far back as 1978 with the Pioneer probe. These seem to happen very frequently, and there are possibly thousands of them per day, and it was at first assumed to be lightning. I mean, kinda makes sense. This was technically later confirmed by other probes orbiting Venus that were able to detect very unusual radio emissions known as Whistler waves. These are actually very well-known phenomena that happen around Earth all the time. These are radio signals coming from the atmosphere of planet Earth that we know today are caused by lightning. In this case, when the lightning strikes somewhere on the surface, quite a lot of radio waves tend to be emitted from the lightning and travel away from planet Earth, in the process creating a kind of a whistling tone, which is why they're known as whistlers. They were actually originally discovered by various radio operators listening to radio frequencies on Earth. And well, it turns out something similar was happening on Venus. But relatively recently, researchers detected something very unique, very unusual. Unlike planet Earth, the Whistler waves on Venus were not traveling away from the planet, they were headed toward it. Which is not what you expect from a lightning or from something happening on the surface. And here the explanation was that it's actually probably the result of magnetic reconnection from various magnetic lines around Venus. And as the reconnection happens, it basically sends these waves toward the surface. So it was not lightning at all, which actually made quite a lot of sense and also explained why some of these Whistler waves were so frequent and seemed to be so powerful. Because if these were coming from lightning, it just meant that the lightning on Venus must be like at least 10 times more powerful on average compared to planet Earth. By itself, this kinda did not make a lot of sense. And so here the scientists were actually stuck with a mystery. Is there even lightning on Venus? And that's of course because we actually know very little about the phenomenon of lightning in general. And so here the scientists focused on trying to figure out, okay, well, where are those flashes coming from? Is there maybe another explanation? Every year, approximately 100,000 of these flashes were detected coming from the surface, so it must have been something very common, and it must be something relatively powerful. But what can it be? So one of the teams decided to take a different approach. They actually realized that first of all, Venus is much closer to the Sun, so here things will be slightly different from Earth when it comes to orbital velocities and when it comes to various meteors. Compared to various asteroids and meteorites on Earth, anything striking Venus is going to be moving much faster, and it's very likely going to be more frequent as well. Mostly because Venus is located much closer to the Sun, and because it does not have a moon to protect itself from a lot of other collisions. And so by working out the average number of potential collisions, they actually came out with a number that seems to match the total number of flashes, essentially suggesting that those flashes are very likely the result of meteors breaking up in the upper atmosphere and not lightning. In the process also suggesting that lightning is most likely impossible on Venus. And that's on top of other studies that already suggested there's very little evidence that the Venusian atmosphere is even capable of lightning, or previous findings that discovered there are no radio waves associated with lightning anywhere around Venus, excluding of course the Whistler waves I just mentioned. And that's maybe a very important discovery as well, because we know that generally lightning might have been one of the reasons life started on Earth. And so unless Venusian atmosphere was different back in the days, if it was actually very similar to what it is today, there might have been no life here in the beginning after all. And you can learn more about this idea of lightning potentially causing life in one of the videos in the description. And on top of this, we also had a few studies focusing on the surface of Venus, trying to specifically identify certain features in order to understand how Venus evolved, with one of the studies focusing on mapping volcanoes on the surface. And they actually did a really incredible job. They found 85,000 volcanoes on the entire surface. Here's what all of this kind of looks like. And this is a really impressive work and shows us how extreme Venus is compared to planet Earth. In comparison, the surface of Earth only has about 1,300 volcanoes, with maybe about 20,000 in the ocean. Here though, volcanoes are much larger, appear a little bit more active, and most importantly, some of them actually still appear active even today. Once again, the video in the description talks a little bit more about this, but in a nutshell, recent evidence discovered that there might have been volcanism here as recent as 1991, with at least some of these volcanoes still being active today, and obviously being driven by something we don't understand. With this map and the research behind this, hopefully serving as a foundation for future research in order to help explain the past and the present of volcanism on the Venusian surface. And one of the reasons why there are so many volcanoes here is because the scientists discovered that the Venusian surface seems to be a little bit more squishy and a little bit thinner than previously believed. And it wasn't actually clear why, until another study managed to model this by using various impacts that would happen on the surface here. And so here, various impacts happening on the surface would very likely be much more powerful and much more impactful compared to planet Earth. And because of these high-speed, high-energy impacts, it would actually create a superheated core and a very dynamic surface that would constantly resurface the planet, potentially forming all these volcanoes on the surface and even creating conditions that seem to be still going on today, with many of these impacts being so powerful that they would easily melt up to 82% of Venusian mantle, causing similar effects to what we usually expect on Earth because of plate tectonics. And so because of these extreme collisions that happen on Venus because it's just much closer to the Sun and things in this region move much faster, thus producing more kinetic energy, produced a planet with a lot of activity on the surface, lots of volcanoes, and lots of surface renewal simply because of these collisions and these very powerful impacts. And so that's at least one more explanation for why Venus is the way it is, for why it has so many volcanoes, why the surface here is different, and how it's still able to maintain volcanism even today. Or at least that's what the scientists believe for now. By 2030, 2031, all of this might change because we're actually going to have physical missions coming here, missions that are going to be assessing the atmosphere, the surface, and even looking for life. And so by then, things might change. But at least for now, these are the major discoveries coming from Venus, and the discoveries that help us see Venus in a slightly different light. Not as a deadly, super hot planet that has nothing on the surface, but as something potentially more dynamic, more active, and maybe even containing life. So yeah, we'll definitely come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, check out previous Venusian videos in the description below, share this video with someone who loves learning about space and sciences, come back tomorrow to learn something else, support the channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.